Hello everyone. We got running short on time yesterday at the end of class, so I figured we should talk about saturation real quickly and then go into an example of a solubility curve problem. So starting with unsaturated solution, this is where the amount of solute we put in to our solution is less than the total amount we could put in. So in this example, we've got 30 grams of sodium chloride going into the water. It all dissolves and more could dissolve. So this solution is called unsaturated. Moving on to the next type of solution, we've got a saturated solution. So a saturated solution is when you've got just the right amount of solute dissolved. So if you look at the bottom example here, we take 40 grams of sodium chloride this time, put it into our water solution, and now all of it dissolves except for this tiny little bit here at the bottom, this 4 grams that remains undissolved. What that tells us, the fact that there's stuff not dissolved at the bottom, is that as much solute is dissolved in the solution as there can be, and those 4 grams are just extra that can't possibly be dissolved. If we added another 10 grams, all 10 grams would collect here at the bottom. So we call this solution saturated. All of those lines on those solubility curves represent saturated solutions. So at a specific temperature, you go up to that graph and across, it tells you how many grams maximum can be dissolved in that solution. And finally, we have supersaturated solutions. A supersaturated solution is pretty rare. These don't happen that often. But this is when you have temporarily more than the maximum amount of solute dissolved for a certain temperature. Okay, just for a little while, you can keep the solution, everything dissolved, until this point when you've got what we call a seed crystal or some sort of disturbance that causes the solution to crash out or crystallize out, might be the term you might see. So let's go through the little step-by-step here. First of all, we put in 95 grams of solute. 5 grams starts dissolving. It's unsaturated. We've still got lots left to dissolve. Later on, 91 grams have dissolved at the same temperature, and 9 grams just refuse to dissolve. That means this solution here is saturated. Okay? Red triangle means that we're heating it up. So you notice the temperature changed to 50 degrees. Now we've gotten all 100 grams to dissolve. Okay, so we've heated it up. Everything is dissolved. Okay, so we've changed that. Now that it's hotter, it can dissolve more. So this is now potentially unsaturated, could be saturated. We don't know what the solute is, but it's definitely not supersaturated yet. If we allow it to cool nice and slowly, and we get back to this 25 degrees temperature that we started at, and all 100 grams are now dissolved at this 25 degrees, now we have our supersaturated solution, because before only 91 grams would dissolve. Now we've got 100 grams. And if you put this seed crystal, if you dropped one little crystal into this supersaturated solution, or even if you stuck a stir rod or a thermometer in there, that's going to be enough of a disturbance to cause this 9 grams to crystallize out and sit on the bottom again. And now we formed back into a saturated solution. Look at a specific example that I set up. We've got a solubility curve here, and it says how many grams of NH3 can be dissolved in 50 grams of water at 10 degrees. So NH3, if we're looking at our solubility curve, is here. And at 10 degrees Celsius, if we follow 10 degrees up, hit our graph, and bring it over, we should be able to dissolve 70 grams of NH3 for every 100 grams of water we have. This particular example, we've only got 50 grams of water, so how many grams of NH3 can we dissolve? Half, 35 grams of NH3. Part B, if the water is heated to 90 degrees, how many grams of NH3 come out of solution? So let's look at 90 degrees. 90 degrees up to NH3, hits the line right away. Bring that across. And we see that if we had 100 grams of water, we could dissolve 10 grams of NH3, but since we only have 50 grams of water, that means at 90 degrees, we can only dissolve 5 grams of NH3. So if we heat from 10 degrees Celsius up to 90 degrees Celsius, we're going to go from being able to dissolve 35 grams down to only 5 grams, which means 35 to 5, we're going to lose 30 grams of NH3. Is not going to be able to dissolve anymore. And what is NH3 going to do? It's going to come out of solution as bubbles, because NH3 is a gas. That's why its solubility decreases with temperature. So 30 grams of NH3 are going to bubble away and no longer be dissolved. If this was a solid and we were cooling it down, the solute would come out of solution in the form of just crystals at the bottom, solid at the bottom. But if you're talking about a gas leaving the solution, it bubbles away. Hopefully that much explanation is enough. If not, we'll recoup and go over stuff on Wednesday. Do your best with these homework problems, work together, and I'm sure you can figure this out. If the sub has not told you yet, the homework problems I gave you yesterday, you can hold off on number 4 until at least you've seen this video, and 11A, we can talk about that one when I get back on Wednesday. But the rest of them you should be able to have a good go at. We don't need to do a part C here. All right, good luck.